Right here. So last time we were together, on page 33 of our notes, problem 4, we had done all of the calculator work, except we only got through the degree problems. Do you remember that? Okay, so first thing we need to do is turn our calculator on, then we need to go to mode, and remember mode is right here, right next to the alpha button. And when we press mode, this is how we pick our options, right? All of these angles are in radians. How do I know? There is no degree mark. You know degrees because it'll say degrees. If it doesn't say degrees, then it is in radians. So there's no confusion here. That's a radian measure because it doesn't have a degree, okay? So I'm going to make sure radian is highlighted. I'm going to click down, highlight radian, press enter, and then I can just second quit and go right back to my home screen. I have selected radians, so at this point, every angle I put in, the calculator is going to think it's radians. Okay, so we're going to type in cosine pi over 9. Now luckily we have a cosine button, so we're going to press cosine, and then if you look over in the last column of buttons, you see your pi? It's right under the clear button, you see it? So we need that. We're not typing in anything else, we're using the pi button. So second pi divided by 9, and see if the answer you get is 0.9397, if I round it off. Is that what you got?
Yes.
That's the right answer, you typed it in correctly. All right, so now we're going to do the next one. Now this one, we're going to do the same thing, but the problem is you don't have that button. So how did we decide we were going to put a cosecant into our calculator, Lauren? 1 divided by sine. Remember, the cos never go together, so cosecant will never go with the cosine. It's 1 divided by sine. So we are literally going to type in 1 divided by sine, and then 5 pi divided by 16. So 1 divided by sine, 5 pi divided by 16. Oh, I got 1.2027. Okay, 1 divided by sine, 5 pi over 16. Same situation, only this isn't 1 divided by sine, this is 1 divided by cosine. So 1 divided by cosine, 18 pi divided by 23. Negative 1.2891. Do we match? Everybody matching okay? All right, last one, cosecant 2. Well, you don't have a cosecant button, so what are you going to press? 1 divided by sine 2? .0998. 1.0998. Okay, now let's take a look at that practice quiz, because that practice quiz has some of those problems on it. So let's just start at the beginning of the practice quiz. And see what we can remember. 215 degrees, we're going to change it into radians. Anybody remember how we do that? Yeah, Mamuna. Yep. We set up our proportion. So pi over 180. Perfect. That's exactly right. That's the way that's set up. This is a degree measure, that's a degree measure. Right? It would cross multiply. So 180x equals 215 pi. And x equals 215 pi over 180. Now you will not have a calculator for the front side of the quiz. The back side of the quiz you will, but the front you're going to be on your own here. So I need to reduce that. What might I divide by to start reducing that? 5, that's a good choice. So over to the side, I'm going to do the division. I got 43, and then 180, 36. Am I done, or do you think that reduces further? I'm done. 43 is a prime number, right? So we're done. That's it. All right, everybody remember how to do that? Now the next one says, find the exact value of the tangent of pi over 3. Okay? Now first of all, anytime you have a tangent, or a cosine, or a sine, or anything, it's going to be a fraction. So the TOA, right? It's a fraction, opposite over adjacent. So the first step of the problem, you're probably going to deal with this, but that's not the answer. That's the first step. Tell me about pi over 3. 180 divided by 3, so this is the same as 60? So we're finding the tangent of 60. I can't tell you how many papers I graded, gang, where people stop there. Okay, that is not the answer. The answer is going to be a fraction. Well, how do I go about finding that fraction, the tangent of 60? I draw a picture, and I set my triangle right there on the axis system, just like that. Remember from the other day? And the angle always goes here at the origin, so I'm going to put the 60 right there, which makes this the opposite and this the adjacent, right?
Yes.
So my answer is going to be that over that. What are the numbers?
30.
Well, it's a 30, 60, 90, right? So 1 goes here, root 3 goes here, and 2 goes here. How do I know 30, 60, 90, 1, root 3, 2? That's how I know. Across from the 30 goes the 1. Across from the 60 goes the root 3. So what's my answer? Opposite over adjacent, root 3 over 1,
Have a fraction of.
which I'm just going to write as root 3.
I thought you could have a square root on the top.
Oh, no, no, no. You can't have a radical on the bottom.
No.
The top is fine. But there are problems like this where we get radicals on the bottom and we have to fix it, but this isn't one of them. Okay, next. I'm going to draw exactly the same picture. Anytime they don't give me the picture, I'm going to draw this one. And I'm supposed to find sine, cosine, tangent, cosecant, secant, cotangent. See how I've lined these up? Reciprocals. And they need to give me something. What did they tell me? They told me that the cosecant is 5/2. Here's beta. If the cosecant is 5/2, what's the sine?
2/5.
2/5. And what's the definition of sine? So, Katoa. Opposite over hypotenuse. So in that triangle, the opposite side must be 2, and the hypotenuse is 5. So what do I do now? A squared plus b squared equals c squared. We call it the Pythagorean Theorem. And c squared will be 5 squared. So I'm going to say x squared plus 2 squared equals 5 squared. Is that right? And so x squared plus 4 equals 25. X squared equals 21. And what does x equal then? Root 21. Now, we know this is opposite, this is hypotenuse, this is adjacent. Looking at theta. So here we go. What's the cosine? What is it? Root 21 over 5. What's the tangent? Well, it starts out as 2 over root 21, but some of you automatically go to the final answer, which is this, which is fine. This is the answer.
Okay.
And then we need our reciprocals. What's the secant? Well, the secant is going to be the flip of this, right?
Yeah.
So it's going to be 5 over root 21. Or 5 root 21 over 21. And the cotangent is going to be the flip of this one. So it's going to be root 21 over 2. Jackson?
If you put 5 over root 21, will that like be more?
It won't be marked totally wrong. It'll be marked a little bit wrong. And since that happens a lot, all those little things are going to add up. There's no question that when you get to be, you know, in your differential equations or something, they're not going to worry about that, but right now we are. So, yeah, we're going to rationalize it. Okay, everybody all right with that? Lots of pieces to it. Okay, which function is r over x? Think about it, what? It's secant. It is secant. X over r is cosine, so secant would be the reciprocal. That is exactly right. What is the reciprocal of cosecant? Sine. Sine. Define tangent. Opposite over adjacent, or what's the other one? Oh, whoa, 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 whoa. Y over x. Tangent is y over x. Okay.
Do you have to put both of those on?
No, not unless it says with the ones both. All right, turn it over. All right, here we go. Now, what do you have to pay attention to? You're going to turn your quiz over tomorrow, Monday, and you're going to have a bunch of problems just like this. What do you have to pay attention to? What mode? That's exactly right. Am I in degrees or radians? Well, we just finished doing a bunch of radian problems, right?
Yeah.
So my calculator is set in radians. So I'm just going to leave it, and I'm going to go through, and I'm going to do this problem and this problem. These are radian problems. Notice all of these have degree marks. These two don't. I need you to understand it has nothing to do with the pi, because not all radians have pi's and some degrees have pi's. It has to do with the fact there's no degree mark. That's how we know. All right, so here we go. Start with this one. We just practiced this. So we'll press sine 201 pi divided by 8. Negative 0.3827 is what I got. Anybody confirm that? Thank you, Mamuna. Okay, and then this one we have one more, cosecant. What do I do for a cosecant? 1 divided by sine. Negative, and make sure you're using the negative, not the minus. Use the negative. 19 pi divided by 77. Negative 1.4289 is what I came up with. Mamuna, you confirm?
Yes.
All right. Now what do we have to do? Now we have to change our calculator into degrees in order to do the rest of the problems. So we go to mode, we go down, highlight degree, press enter, and then we can type in, okay, do we remember how to do this? Cosine 20. What do I do now? Second apps, go to my angle menu, choose degrees, 18, go into my angle menu, choose minutes. Should be 0.9379. Whoever's beeping, please turn it off. Christian, can you take off the plaid jacket? Next one, easy, tangent, negative 2018, negative 0.7813. Uh-oh. Remember how to get all that? First of all, secant. How do I even start, what do I even do to start with? 1 divided by. So 1 divided by what? Cosine. I'm doing secant, so it's 1 divided by cosine. 1 divided by cosine. And then 2 second apps degrees. 1 second apps minutes. And then 8 alpha plus 1.0006.
Yep.
And then last one, 1 divided by tangent, 1977. That's the year I graduated from high school. I know, it seems like centuries ago. Negative 19.0811. Okay, when's this quiz? What do we have to make sure we have? Yep. Yep. So, and make sure that if you have not been bringing your calculator to class, you've been sitting there while the rest of us are doing it, practice those at home. You now know what the right answers are. Practice them at home. It's all the steps are on video here, so you can do it. The biggest mistake that's made in this calculator section, can you guess what it is? The mode. People forget to change that. So my recommendation is you check to see how it's set, and if it's set in degrees, then go through and do all the degree problems. Then change it to radians and do all the radian problems, okay? Don't try to be switching back and forth, that's when we make a bunch of mistakes. Okay, so now we're ready to get our notes out. back out, and we're going to continue plowing through. So that right there is what's on the quiz. We're going to talk about some additional things. That's not on the quiz. All this is on the quiz. We do have open gym on Sunday. Of course, we have flex today. We don't have flex tomorrow because you guys have your class mass during flex.
Hey.
But we do have flex today. And of course, we can do quiz practice at that time. All right, so here we are. We're on page 33, number 5. This is backwards. Oh my golly. They are asking me, without a calculator, to figure out what angle has a cosine of 1/2. Okay? They didn't draw me a picture, so I'm going to draw my own. And remember, I've been kind of harping on this fact that when you are constructing your own picture, you want to set it up like this. This is how you want to set it up. And theta would be right here. Always at the origin. The angle is always at the origin. Jacob, you want to wake up? Okay. Now the cosine is 1/2. What do I know about cosine? Adjacent over hypotenuse. Does that make sense to you that I would draw my picture that way? Now you should recognize those two numbers. If that's a 1 and that's a 2, what's this one got to be? Square root of 3, right? Now what angle does that have to be? Look at this configuration of the sides there. Clearly it's a 30, 60, 90 triangle because those are the 30, 60, 90 numbers. What goes across from the root 3? 60. So theta is 60 degrees. It's that easy. That's the angle. That's the answer. So we're just doing our triangle backwards. This one is harder. And it's harder because in order to do it, you really need to recognize that this has been rationalized, okay? I want you to think about some of the problems we've been doing. We had a problem the other day where it said, like the cosine was 1 over root 10. But we didn't leave it as 1 over root 10. We rationalized it, right? And what did it become? What did this become when we rationalized it? Root 10 over 10? So the answer is root 10 over 10, but it started out as 1 over root 10. Let's look at another one. What if I told you that the tangent was 1 over root 5? That'd be root 5 over 5. So what you need to do is work this one backwards. What did that start out as? That's the final answer, but what was it originally? 1 over root 2? So this was originally 1 over root 2. Before it got rationalized. So here's my picture. The sine is opposite over hypotenuse. Do those two numbers look familiar to you? If yeah, this is a 45-degree angle, isn't it?
Yeah.
So theta is 45 degrees.
Okay.
Cosecant equals 2. Now remember, all the functions, sine, cosine, tangent, secant, cosecant, cotangent, are all fractions. So think of 2. I know it says 2, but it's 2 over 1. It's a fraction. Right? So in this picture, something is 2 and something is 1. 2 and 1 is 1. 1 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 and 1 is 1. What's 2 over, there's opposite, adjacent, hypotenuse, what are
Is that
those?
cosecant?
What?
Is that cosecant?
It's, yeah, that's cosecant. Hypotenuse over opposite, right? You thought it was nuts when I told you to memorize this stuff, but you have to memorize it. So it's hypotenuse over opposite, so 2 over 1, which makes this side root 3. And I want the side that's across from the 1, so theta is 30 degrees. This is kind of like a puzzle. So we're going to think of tangent as a fraction, 1 over 1.
Adjacent.
Well, tangent is opposite over adjacent. Not that it matters since the numbers are the same in this problem, but tangent is opposite over adjacent. So that's 1 root 2. Which makes this angle how big? 45. Secant is 2 over root 3. What is secant? Hypotenuse over adjacent?
Yeah.
So the hypotenuse is root 3 and the adjacent is, backwards. The hypotenuse is 2 and the adjacent is root 3, which would make this side a 1. It's across from the 1? 30. So the answer is 30 degrees. One more. Cotan is root 3 over 1. Think of it as a fraction. What's cotangent? Adjacent over opposite. So adjacent is root 3 and opposite is 1. Obviously hypotenuse is 2, but you probably don't even need to do that because you know that across from the 1 is 30. If you're not using a calculator, every single one of your answers is going to be 30, 60, or 45. Because those are the only angles we can do without a calculator at this point. There'll be others we kind of learn as we go on, but right now, that's it. Okay? All right, get those calculators back out because now you'll see the next set of problems are full of 28s and 52s and 13s. There is no way that you can do these without a calculator unless you have a trig table. And those are so outdated, they don't even put them in the books anymore. Okay, so they drew me a triangle. I'm drawing it just like they did. And I'm supposed to figure out what x is. Now, you are going to use sine, cosine, or tangent. You certainly could use secant, cosecant, and cotangent, but that would just not be smart because I don't have those buttons on my calculator. So I'm going to stick with what I have buttons for. So I'm going to look at this problem, and I'm going to think about whether I want to use sine, cosine, or tangent. Now, here's the angle, right? We never use the 90. Never use 90, always use the other angle, so 28. With regard to the 28, which side is this? Opposite, adjacent, or hypotenuse?
Opposite.
This is opposite. Which side is this? Hypotenuse. Now, the adjacent has nothing to do with this problem. So I need a function, sine, cosine, or tangent, that uses opposite and hypotenuse. Sine. So it's sine angle. The angle always goes with the sine, or the cosine, or the tangent. So it's sine angle equals opposite over hypotenuse. We picked sine because opposite and hypotenuse were involved in the problem. When we write our equation, it's always sine angle, or tangent angle, or cosine angle, and then equals the fraction. Now we need to solve that. You can't solve when the variable is in the denominator, so I'm going to bring that over here and write x sine 28 equals 10. Does that make sense to you? Multiply both sides by x. And now I need to get x alone, so I am going to divide by the sine of 28. This is a block. You cannot separate those two from each other. They go together. So when I divide, I'm dividing by sine 28. So then I'll go to my calculator. Oh, by the way, see that right there? How should my calculator be set? In degrees. So the first thing I'm going to do is check mode. I'm in degrees. I happen to be in degrees, which is good news. So I'm going to type 10 divided by sine 28. And I got 21.30. I'll round off to the nearest hundredth. I'm just randomly rounding off because there aren't any directions. Don't worry about it. Just make sure you're getting 21.30. Are you getting that? Good. Let's try the next one. Again, when they draw the picture, you got to go with what they draw. Do you remember what was the first thing I got to think about? What is it? Is it sine, cosine, or tangent, right? So let's look at it and see. With regard to the 13, Gideon, you with me? With regard to the 13, what's this side? Opposite, adjacent, or hypotenuse? This is adjacent. And what about the x? Hypotenuse? So what function will I use? Cosine. So I'll say cosine 13. Remember, the angle always goes with the function, the sine or cosine or tangent. So it's cosine 13 equals what? 4 over x. Perfect. That x is in the denominator again. Sometimes it's on the top, sometimes it's on the bottom. If it's on the bottom, you got to bring it over. And then divide. Everybody follow that? It's just like the last one. So 4 divided by cosine 13. 4.11. Bless you. All right. So, Brock, what's going through your mind right now other than I'm watching the clock, can't wait to get out of here? I got to find what function I'm going to use, and I figure out what function I'm going to use. And when I say function, I mean sine, cosine, or tangent. To figure that out, I got to look at my triangle, look at the angle, Which side is x? Opposite. Which side is 5? Adjacent. And that tells me what function I'm going to use. Opposite and adjacent would be tangent. So I'll write tan 52. The angle always goes with the tangent, or the sine, or whatever. And what is tangent going to equal in this problem? X over 5. Well, this time I'll bring the 5 over. So x equals 5 tan 52. And I will go to my calculator and type in 5 tan 52. And I get 6.4 basically. It's 6.3997, so 6.4. All right, so you're getting the hang of it a little bit. All right, let's try the next two on our own. There's two more, D and E. And maybe a volunteer, a couple volunteers would come up and put the work up here for us. Well, come up and do this one. You got it. You can do this one. It's no different. Looks a little different, but you got it. I'm totally confident. Come on, I'll help you. What sides do you have? 63 is your angle. Oh, wait, 63 is your angle. Right? No, you got to do that. High five. So Katoa.
Oh, you feel that down. David, I'll show you what the keeper put in power school. I'm going to show you what keeper put in power school. A plus. A plus.
Yep. Cosine 63 is a unit, so you're dividing by cosine 63. The whole thing. Yep. All right, what do you think about Brent's problem? Did he get that right?
Yeah.
I don't know, I haven't checked it. I left my calculator somewhere. Let's see. You set it up correctly. So unless you typed it in wrong, you should get it right. Yes, I got it. Now, let's take a look at these two problems because when you do this, thank you, there's only two things that can happen. You're always going to have your cosine equal to a fraction, or your sine equal to a fraction, or your tangent equal to a fraction. So regardless of whether the x is on top or bottom, you have to get rid of the denominator. So in this case, when he brought the denominator over, he had x. He's done. He just types it in. Here, when he brought the denominator over, he still had to do a division. He had to divide by the cosine of 63. But we do all the problems exactly the same way. Does everybody understand why both guys used cosine?
Yes.
The problems are set up differently, the angles are in different spots, but it doesn't matter. You look at the angle and which two sides you have. Adjacent hypotenuse, adjacent hypotenuse. Okay? Now, the moment you've been waiting for. What in the world can we do with all this newfound information? Well, we're going to do some word problems. So let's look on page 34. Problem number 7 says, draw a picture, write an equation, solve it. All right? So here we go. We have a squirrel sitting in the top of a tree that is 52 feet tall. So here's the ground, here's the tree, here's the squirrel. The tree is 52 feet tall. The squirrel is looking at a nut on the ground. Kind of see what's happening here? See that right triangle? His angle of depression is 23 degrees. When you were in geometry, you guys talked about angles of elevation and depression. Technically, this is the angle of depression. Because an angle of depression says look straight ahead and then look down at something, and that angle that your head tilts through is the angle of depression. The problem is, that isn't even in the triangle. The angle of depression isn't in the triangle. So we know that this is the same thing. This is the angle of elevation. So in other words, if I were a worm in a nut looking up at the squirrel, that would be the angle I tilt my head through, and those two match. Every time they say angle of depression, you can mark it as an angle of elevation because these two will always be the same. How do I know they'll always be the same? When parallel lines are cut by a transversal, alternate interior angles are congruent. So, when I read the problem, I am not going to mark the 23 up here. I'm going to put it right here. Every angle of elevation or depression can be marked right there. So simplify your life, put it there. Every time.
Will it always be marked there?
Yes. What did I just say? Every angle of the elevation or depression is going to be marked right there. Okay? Now, what do I want to know? Find the distance from the nut to the base of the tree. So does everybody understand that that's x? Now, if we had said find the distance from the nut to the squirrel, then that would be x up here, right? But we want nut to base of tree. Okay, there's the picture. Now we're going to write an equation, which is exactly what the guys just did when they were up here. There's your angle. Which side is the 52? Opposite. Which side is the x? Adjacent. What function am I going to use? Tangent. So tan 23, remember, the angle always goes with the tangent, or the sine or the cosine. So tan 23, and they're not separable. They stay together. Tan 23 equals opposite over adjacent. Right? So now we clear our denominator. So x tan 23 equals 52. And then we'll divide by tan 23. Remember, these two cannot be separated. You can't divide by tan and you can't divide by 23. You have to divide by tan 23. So, type it in on the calculator and we will know the answer to the question. 52 divided by tan 23, I got 122.50 feet. Remember, it's a word problem, so we always label our answers in a word problem. Well, wasn't that fun and invigorating, all of you out there that are falling asleep? That was exciting stuff. Let's see, let's do the next one. A seagull on the top of the lighthouse. So here's the ocean, here's the lighthouse, here's our seagull. He's on the top of a lighthouse. He spots a fish in the water below. Please don't make your drawings hugely elaborate. They're all going to be right triangles. The gull is 87 feet above sea level. The gull is 230 feet from the fish. Where does the 230 go? Hypotenuse. Hypotenuse. There's the bird, there's the fish. They're 230 feet apart. Find the angle of elevation, or angle of depression. Well, we're counting them as the same thing, and we're always marking them right here. That's the angle you want. If I'm the bird looking at the fish, or if I'm the fish looking at the bird, the angle is going to be the same. This is different. This is going to require us to use a new button on our calculator. Well, let's write our equation first. This is the angle. Okay, that's the angle. Which side is this? Opposite. Which side is this?
Hypotenuse.
Hypotenuse. So what function am I going to use? Sine. And it's always sine angle. It's sine angle equals opposite over hypotenuse. Now guys, remember what I told you? These are unseparatable. You can't do anything there. To find an angle on your calculator, you use the inverse sign, in this case, inverse sign button. So if you look at your calculator, do you see what's written right above sign? Do you see this is written right above sign? You use those buttons, sine, inverse cosine, inverse tangent, only when you are finding an angle. So if your question is find an angle, that's the button you type. So second sine 87 divided by 230, that angle is 22.23 degrees. Now I want you to listen to me really carefully because I don't want you to mess this up. It's really easy to keep straight if you slow down and think. You only use these buttons if X is the angle. If X is something else, not the angle, something else, you use your regular buttons. Regular tangent, regular sine, regular cosine. You only use these special buttons if X is the angle. Okay? One more and I will let you escape. Okay? Here we go. How far is an airplane from the airport? You've got to be able to draw a picture. How far is an airplane from the airport? Here's the plane. Here's the port. How far is an airplane from the airport if he is currently 5,000 feet above the ground and the angle of depression is 17 degrees? Now look at my picture. I've done 1,000,000 of these in my life, so that's second nature to me. Does everybody understand why I put the 5,000 here? 5,000 feet above the ground, right? Everybody know why that's X? What does it say? how far is the plane from the airport, right? And then there's my angle. So here we go. What's this? Opposite, adjacent, or hypotenuse? Opposite. Hypotenuse. What function? Sine. So sine 17 equals 5,000 opposite over hypotenuse. X sine 17, bring the denominator over. Not done, gotta get x by itself. So what's x gonna equal? 5,000 divided by sine 17. So 5,000 divided by sine 17. Wow, 17,101.52 feet. All right, you will pick up there Monday. What else happens Monday? We have a quiz.